All right, hi guys, welcome back. We are going to learn about transformations of functions today. So we are going to talk about taking an original function, which we call the parent function, and then moving it around on the graph. So shifting it left and right, moving it up and down, reflecting it, that's a transformation. This one is going to be pretty self-explanatory after we just go over one big concept, and then I think you guys are going to rock it out. So our first question says, how did the transformation of f of x equals x squared, that's our original parent graph, that's the blue line right here. Now I've made it pink. How does it go from that to x squared minus 3, which is the orange one? I guess I can erase this because they're already colored. So this one's probably really easy just to look at. How does the blue function go to the orange function? What happened? Where did the points of the graph go, and in what direction did they go, and how many did they go? Hopefully, you should say that the graph went down 3. Every point moved down 3. 1, 2, 3, new point. 1, 2, 3, new point. Down, 1, 2, 3, new point. 1, 2, 3, 1, 2, 3. That's what it is. Every single point gets moved down 3. How does it change the y-intercept? So this intercept was at 0, 0, and now the new y-intercept is at 0, negative 3. So if the whole graph went down 3, what happened to the intercept? It also went down 3. So went from 0, 0 to 0, negative 3, which is also down 3. 1b says, how did the transformation of x squared go from the blue graph x to the green graph x minus 3 squared? And how does this affect the intercept? So look at the graph from blue to green. Again, pick a point and tell me how it arrived at the new point. Pick a point. Tell me how it arrived at the new point. How did this point become that point? And so on. What direction was every point moved? How did the whole graph transform? This graph, you should look at it, count the spaces. You should say that this graph moved right 4. Okay? And so looking at that intercept, it went from 0, 0, and now it's at, oh, just kidding. It didn't move 4. It went 3. I'm sorry. I was counting the wrong thing. Sorry. So this one went 1, 2, 3. Every point went 1, 2, 3. Sorry. So my x-intercept went from 0, 3 to 3, 0. So it went from 0, 0 to 3, 0, which also went right 3. So before I teach you the big mega rule that's going to help you solve every problem, what's the difference between x squared minus 3 and x minus 3 squared? What does that location of the 3 have to do with the transformation, and how were they different? When it was x squared minus 3, the graph went down, but when it was x minus 3 squared, it went to the right. I'm going to teach you the big master rule. If there's anything at all that you write down today, it needs to be this. This is the most important thing that you write down. If you write this down, you're going to get a 4 on your target, okay? This is what I call like the master formula. So the master formula looks like this. I'm going to write it all out first, and then I'm going to tell you what it all means. Okay? Y equals negative a, parentheses, negative x plus or minus h, parentheses, plus or minus k. And I'm going to tell you what each one of these terms mean. If there is a negative on the outside of, and now you got to get familiar with this word, I'm going to call these parentheses your container, okay? Because we're going to see this formula look a lot of different ways. Sometimes the parentheses are going to be a parenthesis. Sometimes they're going to be absolute value, which looks like this. Sometimes they're going to be a square root, and then it looks like this. Sometimes it's going to be parentheses, and it's going to have a little squared or a cubed or something outside. Sometimes it might even be the denominator of a fraction. But either way, whatever the thing is, whatever the equation has to offer as a container, I'm going to refer to it as that. That way the rules stay the same no matter what chapter we're in. So if there is a negative outside of the container, that is going to be a reflection over the x-axis. Again, if there's anything you write down, it has to be this. If there is a variable on the outside of the container, that is going to be a vertical stretch or compression. If it is greater than 1, it's going to stretch. Because think about it, if you're multiplying by a whole number, you're making it bigger and bigger and bigger. If a is less than 1, it is going to compress the graph. So again, if I'm multiplying something by a half, I'm dividing it by 2, so my thing would get smaller. If there is a negative inside the container, that is a reflection over the y-axis. And we'll talk about what all of this means in a bunch of examples, but again, this is your master lesson right here. If you write all of this down, you are going to be good to go, smooth sailing. So now, there's 2 different shifts, okay? Our shifts are either left, right, up, or down. So left and right is horizontal. I'll write that at the bottom. Remember, left and right is horizontal, and up and down is vertical. Your horizontal shift comes first, okay? So think about it alphabetically. H comes before V, so your horizontal shift comes before your vertical shift. Your left and right shift comes before your up and down shift. So the H is your horizontal shift. And here's the worst part, and you're going to hate me for it, and I'm so sorry, and I'm going to explain it in more depth later, but right now is not the time because I don't want to confuse you. When you see a plus sign, you are going to shift left. When you see a negative, you are going to shift right. Okay, a really good example is right over here. See how this was x minus 3, but the graph moved to the right? I will explain it all later. Now is not the time. I don't want to confuse you. Just remember that the horizontal shift is counterintuitive. Counterintuitive means opposite of what we think it should be. It will take some time for you guys to adjust to that, but I promise by the end of the year, you'll be champions of it. And then remember, horizontal comes before vertical, H comes before V. So then lastly, you have your vertical shift. And this one is normal. Positive shifts up, negative shifts down. So this, you're going to live and breathe this information for the next couple problems and for your target. Again, if you write anything down, write that down, and that's all you're going to need to know. So again, look back to A. There was a minus 3 outside of the container, and minus means to shift down. So that's why our graph went down 3. Okay? So, number 2 says, what is the equation for the reflected graph? How do I reflect y equals x squared minus 2 across the x-axis? All I'm going to do is I'm going to go look that up. So I'm going to look at all of these arrows. Okay, which one of them talks about reflection over the x-axis? And I go, okay, it's got to be on the outside. So I'm going to go down here and I'm going to say y, I'm going to say y equals, I'm going to put the x squared in the parentheses. And that's what's going to reflect it across the x-axis. Okay? So remember, if there's no parentheses there, because there is no left-right shift, but you still need to do something that's either inside the parentheses or outside the parentheses, you can add them yourself, okay? So remember, the parentheses will only be there if there's a left-right shift. Sometimes there's not, and so you add them yourselves, because to reflect across the x-axis, this minus needed to be out of the parentheses, but now it says to reflect across the y-axis, and if I go and look that up, it looks like the negative needs to be inside the parentheses. So I'm going to go negative x squared minus 2. And then over here, what transformations of the graph, absolute value of x, are applied to the graph now? So I've got a number on the outside. I'm going to go look that up. A number on the outside is a vertical stretch or compression. If the number is bigger than 1, it's a vertical stretch. If the number is smaller than 1, it's a compression. So I'm going to come over here and I'm going to ask myself, okay, A is 1/2, and that is definitely less than 1. So I'm going to say it is a vertical compression of 1/2. And then it looks like I've got some sort of container. So my container this time is absolute value bars, but something that separates the stuff that's inside with the x from what's outside with the x. And I have a +3. So I'm going to go back. I'm going to look. Okay, when something is inside the container, that's my horizontal shift. And then I go, okay, if it's adding, it's going to go left. If it's subtracting, it's going to go right. So I back up. I'm adding 3, which means left 3. And that's how you guys are going to write your answers for transformations. So literally saying vertical compression of 1/2 and left 3. Those are the two things. Sometimes you'll see more. Sometimes you'll see like left 3, up 2, and reflection. But you're just writing that out. And when you do it on the target, it'll tell you exactly like where to fill in the things and what to write there. And then lastly, I've got a negative outside of the container. Again, my container is still absolute value bars, but again, it doesn't matter. So I'm going to go look up what a negative on the outside means. Looks like a negative on the outside is a reflection over the x-axis. So I'm going to go write that down. Reflection over x-axis. And then I've got a +2 on the outside of the container. So remember, inside of the container comes first. And then H comes before V. So inside the container is horizontal. Outside of the container is vertical. Okay? You can think of inside and outside too. Those are alphabetical. So I comes before O. H comes before V. Inside is horizontal. Outside is vertical. They both are alphabetical. So vertical shift, I'm going to say up 2. You could have totally gone back and looked that up. You see, okay, I've got a plus something outside, and I see that plus means up, so that's how I know up 2. And that's transformations. Again, if you have any questions, comments, concerns, text me, call me, email me, Canvas message me, whatever you have to do to get a hold of me. I'm always happy to help. If you want me to further explain these videos, I'm always available on Zoom to jump on and work with you either on understanding the notes more or just understanding the target. Anything that I can do to support you, please let me know.